Hello everyone, I'm Ruchi Sharma and today I'm going to introduce the concept of trigonometry to you. So trigonometry, as the name suggests, trigonometry. So this is three angle measurements. So trigonometry can actually be applied to any triangle, whether it is acute angle triangle or obtuse angle triangle. But we initially, when we introduced the concept, that time we studied only on the right triangles. So here you can see ABC is a right angle triangle, right angled at point C. So the side AC is written with small b, side BC small a, and AB, which is the longest side, is denoted by small c. Now, there are certain mathematical concepts which you need to know before you start doing trigonometry. So let's have a look at the concepts which are needed to learn trigonometry better. This is Pythagoras Theorem, which says a squared plus b squared equals to c squared. C here again is the hypotenuse, the longest side. But if in case C you are finding, so because this is c squared, but c is the length of the hypotenuse side, so c is square root of a squared plus b squared. Now you know the reverse of square is square root, and when you take the square root of a square number, then it gives two answers, positive and negative. But length being a positive quantity, so we are not writing the negative sign here, it's just the positive value. Then out of A and B, the two shortest side, if any of them is not known, then we transform the formula. To find A, it's square root of c squared minus b squared, and to find B, it's square root of c squared minus a squared. The second concept is angle sum property. The angle, three angles in triangle, they all add up to 180 degrees. So if two of the angles are unknown to you, we can always find the third angle. Now the third one is solving equations for unknown. The algebraic equations, generally we learn how to solve them. So you are solving an equation for an unknown. For example, like I've written a very simple example. So 2x plus 5 equals to 0. So you know this plus 5 needs to go the other side, becomes negative 5, and this 2 in multiplication on the other side comes in division. So the value of x, which is negative 5 over 2, when is substituted here on the left side of the equation, will give the answer to be 0. So that is the solution. The fourth concept which we need to know is angles and parallel lines concept. Parallel lines are the lines which are never intersecting lines, yeah? And if they have been cut by a third line, which is called the transversal, it makes four angles. Angle 1 here, 4, 5, 6, 7, 8. For now, I've just marked 3 of the angles, yeah? Now, these angles are related to each other in some way. What is the relation? So, angle 1 and angle 3, you can see, are both vertically opposite angle. Angle 1 and angle 2 are the corresponding angles. Angle 2 and 3 are also equal, being the alternate angles. So once, if in case you know all these things, we can proceed with the trigonometric concept. Any of you who feels not very confident about these 4 topics, please go and watch the videos to know better, okay? Once you know them, you will be flowing with the topic, trigonometry. All right. Now, coming back to the right triangle again, this is ABC. And there is an angle. The terms associated are the hypotenuse, which is called the longest side, is opposite to angle 90 degrees. You can see this. This is angle 90 degrees and the side opposite is called hypotenuse here. Now, out of the two angles A and C, if suppose I'm marking this as theta, although theta could have been here also, that's all right. But for now, it's here. So the line which is the side which is opposite to the unknown angle theta is always called perpendicular. And the third remaining side is called the base. For the IB curriculum students, this perpendicular is also called opposite. And the base is called adjacent. So it's the same thing, okay? Now, so once you know all these terminologies, we can now start finding the various trigonometric ratios. Because see, what is happening? What did we learn? If out of the 3 angles, any one angle is not known, we can always find the third angle because we know they will all add up to 180. If out of given 3 sides, 2 sides are known and we want to find the third side, then we have the Pythagoras Theorem to find the third side. But what if one angle is known and one side is known and still we want to find other sides? Or if 2 sides are known and we want to find some angle. So this kind of relation when came, then we introduced the concept of trigonometry. Where's the need of this concept? Where are we actually using this concept in our practical life situations? Let's think of an example, like thought about Mount Everest. Like Nobody. Do you think somebody had actually climbed the peak and had dropped a measuring tape to measure the height of the Everest? No. And how do people find the depth of an ocean or a height of very tall building? So there was an instrument which was invented. This is called clinometer, the instrument name. For example, let's think about it. Let me draw a protector here. You all know what is a protector. Okay, and these are the different angles here. All right. Now imagine that this line is the distance in the ground. It's not meeting there, but you can imagine. This line is called horizontal line. Or sleeping line. I'm trying to show you something. If suppose I want to know what is this height of AB here. One thing which is easy to know is the distance from this point. If my position is here, I can know how far am I from point B easily. Yeah, and consider AB to be a very tall building, very tall building or a very tall tree or any tall, statue. And I want to know what is the height of the tree or the building, whatever. So what is possible for me to know? I can know my foot distance from the foot of the tree to my position. This length we can find. What next can we do? We can find the angle. How? Just see this. If I position myself, my arm here, and try to know, putting a searchlight, a torch, and reaching. Can you see this? This is the top of the building, for example, or the top of the tree, or any tall monument. So how much have I opened this pointer from this position to this? This angle we can always read in the protector. So this angle is nearly known to us. So I can, by putting the laser light, know what the angle is, because this angle we can read from the protector. Say for example, in this case, it's 30 degrees. So we know the angle, and you can see there is a big triangle formed. Something like this is formed. This is tree here. This is me standing here. And I know this distance. Maybe it's 5 kilometers for now. Example. We could measure this using the clinometer, that this is 30 degrees. Now we want to know what is this. To know this height of the tree and use the relation of known angle with the distance, we use the trigonometric ratios concept. Now, what are trigonometric ratios? Let's look at them now. It's a triangle again, you can see. Now the relation is between 3 angles and 3 sides. In what way can the sides be in ratio? The ratios could be AB over BC. You can see this. It could have been, just start writing any ratios. If I start writing as BC, which is the perpendicular, over AC, which is the hypotenuse. Or you can write AB over AC, which is again the hypotenuse. Or you can write BC over AB. So these are 3 ratios. And the other 3 could have been the flipped ratios. You can flip these all 3. So this could have been AC over BC also. This could have been AC over AB also. Or this could have been AB over BC also. So we have in total 6 of the ratios. Now how to? We have given some name to these ratios. This one, if you write in terms of perpendicular PBH or if you want to write in terms of opposite, because this is called opposite as well, and adjacent, then we can go with that as well. So adjacent will be A, this will be B, this will be P, O, and H will remain H. So BC can be written as P also. So it can be written as P over H, or we can write O over H. Yeah. Then AB over AC. This can be written as base over height, sorry, hypotenuse, or you can write as adjacent over hypotenuse. That's fine. Then BC, it can be written as P over B, or can also be written as O over A. That's fine. AC over BC is the reciprocal of this, so it can be H over P or H over A. O. AC over AB can be H over B or H over A. And then this will be the third one, which can be written as base over perpendicular or adjacent over opposite. So these are the 6 different T ratios which we are going to introduce. Each of them is named. What is the name? Name is tangent, because this is a relation between 2 sides and 1 angle. Unknown angle, suppose we are taking this as theta. Now, we already discussed that the line opposite to the unknown angle is always taken as the perpendicular or opposite. The longest side is always the hypotenuse, and the third side we name as the base or the adjacent. This angle theta could have been here also. But if it's here, then the perpendicular would be this side. AB will become the perpendicular and BC will become the base for that. So you can always change your side names as per the need of the angle given to you. So now, this is called sine theta. Theta is this angle. And the abbreviation, instead of writing complete sine, we write it as sin theta. They're the same thing. Yeah. Then this one is cosine theta and can also be written as cos theta. Then the third one is tangent theta. And is also written as tan theta. Then you have this one, which is the opposite of sin, can also be written as cosecant. The name is cosecant theta. Now sometimes this is written as cosecant theta. So it's written as cosec theta, or it is also written as this. So they both mean the same. Then the third one, which is this one is secant. The full name is secant, which is the reciprocal of cos theta. AB over AC when it's been reversed, then secant theta, and abbreviation is sec theta. This is the reciprocal of tangent theta, so it's written cotangent is the complete name, and the abbreviated name is cot theta. So we have all 6 trigonometric ratios introduced here. Now you can see each of this ratio, when you notice, has 2 sides and an angle involved. 2 sides and an angle involved. 2 sides and an angle involved. So if we come back to the previous question which we just did, when the foot of the tree was 5 kilometers from my position and the angle was 30 degrees, and we want to know what's the height of the tree. Now angle is the side opposite to the angle is the height of the tree, so that will become our perpendicular or the opposite. And the base is already known to us. Adjacent is already known to us. So this makes a relation. Let's write that relation. Let's see what the relation is. So in that case, it would have been sine or tangent or cos. What is the T ratios which relates a perpendicular to the base? It's a tangent. You can look here. Perpendicular and the base. So that's a tangent. So in this case, it is a tangent. Theta was 30 degrees and that was equals to perpendicular. Perpendicular was the height of the tree which we still want to find. So you can always write x, the unknown, the variable. And then the foot distance from my position to the foot of the tree was 5 kilometers. So this means x divided by 5. So here we need to know how to solve the equation. 5 is in division here. So when you times the equation by 5, you get x. So x is 5 times tangent 30 degrees. So the other thing is that we know that because theta is always one of the angle out of a 90 degrees right triangle. So one angle is 90, the other two can be anything between 0 to 90 degrees. So there are some standard values we always talk about in terms of standard values, the values which are known to us, and trigonometric ratios are known for different angles, okay? So like theta can take the standard values as 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So these are the 5 standard values for which we can write different t ratios. So sine of 30, sine of 45, sine of 60, sine of 90. And same way for all these 6 trigonometric ratios, we can form that table. Okay, for now, this is the introduction to have an idea why we use trigonometry, how we can apply the trigonometric ratios to find the heights or the depths, okay? And apart from this, in the next class, we will learn how to write the trigonometric table for the standard angles. All right, hope you have enjoyed the session and I hope that you have understood it. Thank you so much. See you next time. Bye.